using HTTP request smuggling, we are not going to buy pizza for free, burger for free. So a little less interesting for you because अभी just आप लोग खरीदी करके आए हो, कोई free में burger खा के आए हो, right? All right.
Virtually.
Yeah.
Virtually.
Virtually, yes. All right. So this is more about as he said, like I got first part and about request smuggling. It's always like you will understand, but you will not understand. Like in first place, you will feel like, okay, I understood. Okay, CLT is this. At next place, what was there? TLC, where it was, like you will get confused. So it is always like even today also you will feel like that ki I understood. Then again the stage will come. "Oh, what was there? Exactly in CLT it was there or in TECL it was there. You'll get confused. So please make a note. I'll try to make it clear point by point. Okay. I tried to cover almost all the points, all the attack vectors. A protocol antinomy might be there are few students. How many students are here? Like okay, cool. So there are certain things like methodology, basic foundation you should know before starting with HTTP request smuggling, right? So first we'll see the antinomy, then attack vectors, like what all possibilities, how we can attack, how we can do this smuggling, request smuggling, and exploitation vectors, what all impacts it can create, like using request smuggling, what all benefit we can take, and case studies, and then defense, what to suggest to developers so that attackers cannot smuggle the request. So first of all, let's understand what is 1.0, what is the difference between 1.0, 1.1, 2 and 3. Might be you already know, few of you already know, but otherwise, see, in 1.0, for one request and response, there will be one TCP connection. Connection will get open, request, respected response, connection will get closed. There is no chance to send another request along with it. Only one request, one response in one TCP connection. That's what 1.0 traditional HTTP method is. The next one is HTTP, but what is the drawback of it? For every request, you have to initiate the connection, right? In case of HTTP 1.0, every time you have to, for each request, for each small, for each get, for each post, for each delete, for each and everything, each and every part, you have to initiate a TCP connection in case of 1.2. So it will be slow, definitely. So now HTTP 1.1 comes into the picture. So in this, in one TCP connection, you can send multiple requests. If you once close the connection, then in that case, you have to again initiate the connection, and again you can, like full day, you can send the request. It will be on the same connection. Okay, so that is HTTP 1.1. The next is HTTP 2 and 3. Here we have stream. In HTTP 1.1, we can smuggle request. How? Because we can send multiple requests in same connection time. But in same instance, in same connection, we can send multiple requests. So that there is smuggling, there smuggling is possible. How? We will see. So to overcome from that, we have HTTP 2, where for each request and connection is same, but for each request and response, there will be a different stream. Okay. So you cannot smuggle request. That is not possible in case of HTTP 2 and 3 because this both are based on stream. Okay. One request response will be in one same stream. Okay. So next is HTTP pipelining. Before understanding HTTP request smuggling, you should understand HTTP 1.1 more clearly. Like in one connection, there will be multiple requests, but how they are taking place, what will be the sequence, FIFO, LIFO, what will be there, round robin, what will be there, right? So first, let's understand HTTP pipelining. HTTP pipelining means if connection is open now, right? So you are sending multiple requests. Response is coming or not, but you can send multiple requests. Okay, but that will be in queued manner. Like request 1, FIFO, you can say first in, first out. So request 1, request 2, request 3, and response will come. But in smuggling, how we take advantage of this HTTP pipelining or HTTP 1.1 is when you are sending, see, till now we just understand website, the front end, and the backend server, the database one, from where we bring the data. But there is one more thing, front end server, right? Front end server like Nginx, Apache. So these are the front end server who take requests from browser to the server. Okay. So front end server and back end server. Today's whole topic is based on front end server, back end server. So keep this terminology in mind, FES, BES. Okay. So front end server, at front end server, there is one request. Okay. At back end server, this request is in request one only we have smuggled one more request. How it looks like, we'll see in next slide. Right now in first request only, for example, we have delete request. Inside that only we have smuggled get request. Okay. First of all, tell me how many methods are there? Get, post, fetch, put, delete, this kind of methods are there, right? In get method, is there, like, do we have body inside get method? Yes. Yes. No. In get method, we don't have body, right? We are just retrieving the data just to load the page. For that, we have get method. And for post method, we are creating account or something like that. So you will, the body will be there, like you are putting some data, and that will go to the server. Okay. In patch, delete, put also. So basically, where you can smuggle request, the method, the request having body. Clear? So in get request, you cannot directly smuggle the request. Okay, that is also possible, but not at the first place. So you cannot add some data into get request. Why? Because we don't have body inside the get request. That is clear? Okay. So in first request only we have smuggled one more request. Okay. So for FES we have smuggled, right? So basically it's a one request only for front end server. But for backend server, somehow, due to some ambiguity, it will treat that one request as two requests. And it will gives you two response. How? Let's see by code. So there is some, as I said, FES and BA should be in mind. Similarly, you should remember few headers for HTTP request smuggling to understand HTTP request smuggling. And those are connection, keep alive. What I said for HTTP 1.1, connection is open. That's why we are able to send multiple requests, correct? So connection should be keep alive. And by default, it is keep alive, whether you mention or not. But if you are writing connection close, then your smuggled request will not go ahead. Because after first request, the connection will be closed. And second request will not be entertained. It's going a little heavy, I know, but it will go smoother with time because we have not started with example, okay? With example only you can understood this topic, otherwise it will go from here if you are listening it for the first time, okay? So, see, there are few headers which you should, have to keep in mind. Connection, it should be keep alive. By default, it is keep alive, but you have to take care of it is, it should not be close. There are two values for the connection attribute, keep alive and close. Clear? Okay. The another header is content length and transfer encoding. Content length and transfer encoding. The whole topic again is around front-end server, back-end server, transfer length and content length and transfer encoding. Clear? Okay. So content length value will be the length of the body. The length of the body. You cannot see any escape sequences like /r/n, right? But by default, there is a, like how the request or how the server will understand, like it is the end of the header, it is the end of the body. So it is by /r/n/n CR CL CRLF. Okay, carriage return line feed. Okay. So after each end of each header, there will be /r/n. In Bobsuit also, you can check it. There is one tab /n. If you click over that, you will see after end of each line, there will be /r/n, which indicates end of the line. The like similarly, we have in C, Java, we have semicolon, right? Which makes compiler clear like, okay, this is the end of the line or end of the statement. Similarly, here we cannot see in by default, but if we on that tab /n1, so you will see after each header there will be /r/n. Okay. Why I'm saying that? Because including /r/n, the length will be counted. Okay. So after header completed, there will be one /r/n, and header part is done and body part started. For that, there will be one more /r and /n here above FOXXCON. Okay. See, one /r/n, but after header part is completed, there will be two /r/n. One, this header is completed, and the another one, which is not visible here, I'll show you on in Bubsuit. So another one here. So basically, if there are two /r and /n, that means body is getting start after that. Clear? Okay. So FOXXCON. So you can count how many letters are there in FOXXCON? 7, and that's why content length is 7. Clear? So this is how content length get calculated. Now let's talk about transfer encoding. Transfer encoding is the value of transfer encoding will be chunked. Chunked means the data will be divided into whatever letter. For example, you are having hello world. So the first word will be like 5, then hello, then space plus world will be 6. No, just world, space and world will be 6, right? So it will be example 5, hello, 6, space and world, then 0. 0 is end of the chunked data. Okay, 0 says it is the end of the chunked data. See, in content length, there is the value by which you can calculate, okay, this is the end of the data, end of the body data. But in chunked, how you will understand, because you are not having any calculation part. So if you are getting 0 at the end, because there will be a number, for example, 5, then hello, 6, then space world, and something, something. But if it is end of the data, the number will be 0. Okay, clear? Hai? Okay, because you have to keep this 0 in mind. It is going to come in next slides and next topic also. See, here 0 is end of the chunk data is FOXXCON, and the content length is 7. Done. CL and T separately. This is not a vulnerability. We are just understanding how CL looks like, how content length works, how T works. Clear? Done. Front-end server, back-end server. See, the request will be entertained by front-end server. The response, nothing but back-end server. Clear? Okay. Next. HTTP message. Now that was the request format, how request look like with content length, with transfer encoding. Now we are talking about what MBUT we can take advantage of. So what we are doing, we are writing content length plus transfer encoding. See, in previous example, we were having either content length or transfer encoding. One is enough to use the request, but here we are having both of them. So what to prefer, content length or transfer encoding? So by default, by RFC rule, if content length and transfer encoding both are there in the request, then content length will be override by transfer encoding. Basically, transfer encoding will be preferred and content length will be ignored. Simple. So this also you have to keep in mind. Then front end versus back end mismatch. Okay. Request, response. If both request and response both are using content length only, then there is no problem. 7 FOXXCON, done, right? But if both these servers are using different method, one is using CL, one is using TE, then there will be a problem. So what kind of problems can be there? Like in what scenarios problem can occur? Front end is using CL and back end is using T, vice versa, these combinations, CL.TE, TE, CL.TE, TE. How this will create problem? We'll see in examples. Okay. Till here it is clear. There are different methods. So smuggling is possible in 1.1. In 1.0, connection will be closed after each single request and response. No opportunity to smuggle a request. In 1.1, we can send multiple requests. So we can smuggle a request because in one connection, we are able to send multiple requests. In 2 and 3, the data is properly streamed. It is like encapsulated, one request and one response is encapsulated in one stream. Though the connection is same, but the request and response is encapsulated in one stream. Okay, so that is how HTTP 2 and 3 directly not vulnerable. Indirectly, we will see. Then pipelining and smuggling. Then how CL and T concept we understood. Then RFC rule, like both headers are there, then which one will be prioritized, and what scenarios can be there, like if front end is using this, back end is using this. And this TE means two T's are there. Okay, obfuscated T is there. Like first TE is, for example, instead of content length, there is TE with chumped. And another TE is saying FOXXCON, some random value. So we are just confusing server. Okay, one chunked is understood by server. Okay, chunked is standard value. But if we are saying transfer encoding is equals to FOXCON, what is FOXCON? Server will get confused. So in that scenario, what it will do, that we will see in example in lab also. Now, what all attack factors are possible? So first, HTTP 1.1 desync. Desync means the request part, the front end server uh, taking that request differently as a one request, and backend server treating that request, that response as two part, taking as a two request and giving two responses. We will see in lab, no worries. Okay, so basically desync means one is saying give me water, other one is understanding give me lunch. So basically both are understanding different things. So desync basically both are understanding different boundaries. We'll see. I guess example can only clear you guys. All right. So the three scenarios I have already said, like different, both servers are using different mechanism. So there will be one is using English, another one is using Hindi, another one don't know English. So there will be a confusion, no doubt. The another HTTP2 desync. I said in HTTP2 there is a streaming data. So how HTTP2 desync? Okay, listen, there are, whenever the revolution come, so there are so many front-end server who adopt HTTP2 mechanism, but there are many back-end server, still they use HTTP 1.1. Getting? HTTP2 is implemented on many front-end server, but still there are many back-end server who is not using HTTP2. So FES are there who are using HTTP2, but BES are there who are using HTTP 1.1. So front end will take advantage of using HTTP2, but backend have to use HTTP 1.1 because it is not having any option, right? So in that case, what attacks are possible? What desync scenarios are possible? We'll see one by one. So there is something H2. H2 means HTTP2. Okay, H2 is indicating HTTP2. For that means front end is using HTTP2, back end is using CL. Every time the pair, if you see, front end is using the left one and back end is using the right one. Clear? Okay, that is for HTTP 1.1 desync. Both servers are on 1.1. The second scenario is front end is using HTTP2, back end is using HTTP 1.1. So in that case, scenario is H2CL, H2TE means front end HTTP2, back end content length. Front end using HTTP2, but back end using transfer encoding. Possibilities are there, probability cases are there. And the last one is C2, CRLF injection. How many of you are aware about CRLF injection? Yeah. So CRLF injection, and in HTTP request smuggling, keep one thing in mind. HTTP request smuggling itself is a server side attack or client side attack? Server side. We are talking about front end server, back end servers. The server is getting confused, right? So this is server side attack. Okay. From starting only, I'm not saying client data, client cookie. I'm not talking about that. I'm talking about the servers. From start only, whether I'm talking about request or response, I'm talking about servers, right? So it is server side attack. But beauty of HTTP request smuggling is, if you know HTTP request smuggling, you can create so many, you can impact client side attack. How? We'll see, but keep it in mind. This itself, HTTP request smuggling itself is a server side attack, but there are so many client side impact we can create using HTTP request smuggling. You must have heard about chaining of the vulnerabilities, right? So that will come into the picture, because we are able to smuggle the request. We are able to do so many things. It's not dependent on, okay, we are creating payload and using it and things will happen or will not happen. No. Here we can smuggle a whole request additionally. So we can do so many things. You will get it. Okay. The modern vectors are CL0. So front end is considering CL, means content length, considering content length, and the backend server is considering content length as 0. Okay. Then pause based means time delay. The last one is client side. That's what I said, client side impact it can create. So these are the different attack vectors. In case of 1.1, in case of HTTP 2 used by a front-end server, then these are the possibilities, and modern vectors are this. Okay, let's take one by one, and we'll do labs at the end only. We'll do 2-3 labs. So CL.TE variants, you have to keep your mind open. Otherwise, you will get confused, no doubt. But if you listen to me or if you will ask me question, you will be clear by today. There will be so many confusion. As I said in starting only, you might have read this topic multiple times, but every next time you get confused because there are so many varieties. Front end taking it as differently, back end taking it differently. All right, CL.TE, content length and transfer encoding. Front end is using content length and back end is using transfer encoding. So basically, in this request, what is happening? Content length is 13. Okay. So it will be process smuggled. Okay, if we count 1, 2, 3, 4 and all data, then it will be, see, here it will be /r/n, here it will be /r/n, 1, 2, 3, and then again 4, and then this whole. Okay, this is how some 13 content length is there. So front end is taking, prioritizing or considering what? Content length. Okay, done. Request looks good. Okay, front-end server is passing that request. But back-end server will entertain only transfer encoding. And transfer encoding says if 0 comes, my data body part is done. And when this request goes to back-end server, here 0 comes. So smuggled is the another part. Back-end server will understand that request is finished after 0 again. Transfer encoding means transfer encoding prefers or follows chunked data. Chunked data ended by 0. If 0 comes into the picture, then the data is over. Okay. So in this request, we have crafted a request in a way that 0 is coming in starting only, or maybe you can write here hello world, then 0, then smuggled. So hello world until 0, backend server will consider, and the other rest of the part backend server will understand like it is another request. Okay. Okay, so this is how CL.TE desync will happen. Okay, you can smuggle a request basically. Okay, next is TE.CL. Now front end will use transfer encoding, means chunked. It will follow chunk data, 0 came, done. And backend server will use CL, content length. Okay, so example is this time chunked. So front end saw, okay, 0 came, done. Request is good to go. Request went from front end server. But at the back end, content length is what? 3. So 1, 2 and 3, done. Rest of the part considered as a smuggled request, another request. Okay, take your time but understand this. See, TE by front end server. So TE saw 0 came, okay, request looks good, and took the whole request and went to backend server. Now backend server is taking content length. Backend server is nothing to do with transfer encoding because backend server is using CL mechanism. So he will see, okay, 3, 1, 2, 3, done. The other rest of the part. Smuggled means there is one more request or crafted some data. Okay. So backend will consider this part as another request. Hope you are not getting confused with this 0 for the backend. Backend has nothing to do with 0 because backend is using CL mechanism. So it will just see content length and request is done. Okay, the third variant is TE obfuscation. Now we have two transfer encoding. We are not going to consider content length right now. So we have two transfer encoding. One is saying chunked, the another one is confusing server, some random value. So the front end will consider it as okay, transfer encoding chunk, the first TE it will see and it will go, okay, done, 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 0 came, the request good to go, right? But at the end of the backend server, transfer encoding chunk, the another transfer encoding FOXXCON, backend server will get confused. Now what is the solution for this? Now what it will do? Backend server need to take some decision.
It will jump that off
That will happen, but what it will check? Content length, transfer encoding, what to do? See, eh, now, initially what we said, if server, see, if you don't have any solution, you will go with whatever you're having in your hand, whatever you're having in front of you, right? You have to decide something. So transfer encoding is confusing backend server. So it will prioritize content length. Now it will see 4 and 1, 2, 3, 4 done. The rest of the part will consider as a second request. Okay? Okay. This was TE obfuscation. We are confusing backend server. Okay? Little tough. Little tough it is going, I guess. Right? Wrong. You want more tough examples? Okay. They are also coming. Okay, just have look for 1 minute, as I always do in my session, because it is going to go more heavy, because we are going to see almost 8 to 9 examples. So CL.TE pattern, front end CL, back end TE, TE means ended by 0, 0 came, request done, okay? And CL, content length counting will happen, then TE.CL, then TE obfuscation. So we are trying to confuse backend server get confused by this some random data, it will prioritize, it will check content length and it will proceed. Okay. The another one is CL0 detection. CL0, CL for front end, back end ke liye 0, right? What is the meaning of the 0? Back end considering content length as 0, okay? This is not simple 0 or some transfer encoding chunk data 0. It is saying front end CL, whatever CL is there, that will be considered. By back end, CL will be considered as a 0. Clear? Okay. You can see the example. Okay, this is the request. Okay, this is front end and this is back end, how they are taking. So that is the request. Front end will consider this 53. Good to go. The whole part it will take and it will send it to the backend server because the total is 53. You can simply count this in hexadecimal. If you have seen in the previous example, you can see 5C, right? You have to count the whole in case of chunked data. If it is going, we saw 5, then hello, space world 6. But right now we are having more data. So we have to calculate the whole data including /r/n. And one /r/n will be considered as a 1 byte, not 2 /r/n, no. The together CRLF, the whole together 1. Okay. So fine. Now you can see this request. So here we are having content length 53. Front end will consider 53, but back end will consider content length as a 0. Perfect. So content length 53, good to go. Front end server process the request, but back end server will consider content length 0, means body ends here only. So other part will be smuggled request, another request. It will consider it as a another request. Okay. So the overall, if you observe, then this all mess is because of different mechanism used by different servers, right? One is using T, one is in TE also. If you see, one is taking this first T, the one is taking backend server is taking next T, getting confused using content length. Basically, every time one is using content length, one is using transfer encoding, or vice versa. That's why the problem is there. So in this also both are using content length, but one is considering the value of content length. The another one is considering 0. Okay, content length as 0. Okay, these were the different variants. Now delay. CL.TE delay. Listen to it carefully. So in this case, what will happen? Content length is 5. Okay, FOXXC is taken by front end server. Good to go, done. Front end looks good. Now it's time for the back end. TE, transfer encoding. Now it's time for chunked data. So here will be like after this we don't have any 0. So backend server is waiting for 0 because it is working on transfer encoding mechanism, right? In every request, see we have 0 at the end. This is how server understand, okay, this is the end of the body data. Okay, but in this case, we don't have 0. Server is waiting for 0, waiting for 0, waiting for 0. By default, this is the delay. Okay, so this is CL.TE delay probe. Okay. The another one is TE.CL. Now front end is taking TE, backend is taking CL. Now listen, in backend, that's the request, this is the request. Now front end is taking TE, 0 came, good to go, done. But backend will check this 10, and backend is not getting 10 values here. It is getting less than that. So it will wait for more data, like 10 values, right? Because content length is 10, but we are getting just 5 letters. So there will be a problem. It will wait for 5 more letters. So there will delay will be created, right? This is the TE.CL delay, timing delay probe. Okay. So what all things we have seen? CL.TE, TE.CL, TET or TE obfuscation we can say. You can say it with me. And then CL0. And then delay, CL.TE delay, TE.CL delay by giving insufficient data to the backend. Okay. The next one is now HTTP 1.1 done. In HTTP 1.1, both the servers are using HTTP 1.1, right? Sorry, both the servers are using HTTP 1.1. Those attack vectors we have seen. Now HTTP 2. Okay, so in HTTP 2, we are having different stream for each request and response. I am mentioning this for third time, right? Okay, each request response will be encapsulated in one stream. So no chance of sending additional request. But what happens is front end is having HTTP 2 mechanism, but back end is using still HTTP 1.1. So you have to downgrade. Like you cannot say front end like you also don't use HTTP 2. At least be safe 50% of the time, right? So HTTP 2 will be used by FES, but backend will use HTTP 1.1. So basically what we have to do is downgrading. Like the one is using 2 and the response or the backend service is using the downgraded method, which is HTTP 1.1. Okay. So the first part is downgrading. So basically any cloud, AWS or Nginx or any server which is on front end, they are using HTTP 2 method, and from there you have to make backend server understand like how HTTP 1.1 will look like for the respected request. Now the next is H2CL. Now this is all regarding HTTP 2 using front end is using HTTP 2. Okay. So the first scenario will happen is H2CL desync vector. Front end is using H2 means HTTP 2 and the backend is using CL. Backend is using, H1 is there definitely, but in H1 we have two options, CL or TE, right? So backend right now using CL. See, there is one more example where we'll be considering TE. Like there can be CL, there can be TE. So we are having different scenarios. So in H2CL, the front end is using H2, the backend is using CL. Okay. So you can see the request and response. Hope it's clear. Yeah. So these are the streamed data. In one stream, there are different part. Okay. So content length is 4. This is the whole single request on front end server. Okay. Now backend will just entertain content length. Okay, their backend is not going to stream the data because it is based on HTTP 1.1 method. So content length 4. Okay, 1, 2, 3, 4. Done. Okay. Rest of the data will be considered as a perfect another request. Okay. So this is how even my front end server or one of the server is using HTTP 2, still there can be a problem. Okay. So the next is H2TE. In H2TE, again, transfer encoding will be entertained. So if 0 comes, then request ends, right? 0 comes and the other part of the request will be considered as a smuggled request or another request. Yeah. CRLF header injection. At the end of the request, what we are going to do, some random data, anything, FOXXCON or whatever, and then we are giving one header, for example, cookie or any header. That will get combined because see every time what it is doing, considering it as another request. So it will get combined and one header will be like here we are taking transfer encoding chunked with that. It will be some cookie data or some any header, right? Okay. So we'll go for exploitation vector or labs. Okay, exploitation vector, let's see. So what are the what all are attack scenarios? So front end bypass and request rewriting. So in front end bypass, writing CL.TE, those all examples will come here. CL front end bypass, because front end server is going good, but at the back end server, request is getting interpreted in another form. Okay, so that is front end bypass and request rewriting. Like we are crafting the request. Sometimes we are ending with 0 and then we are writing something additionally in that, so that we can smuggle our request. Or in case of CL, also we are writing content length, and we are including that smuggle data. We are counting that smuggle data also, and we are giving the content length. Okay. The second one is capture request and zero click accesses. So I have said earlier, like using itself, HTTP request smuggling itself is a server side attack, but it can create so many client side, impact. So you can see in this request, our original request is this, the above one, and in this we are adding one endpoint of comment. Okay, we are not accessing comment endpoint directly, but we are adding it into this. We are writing some comment, and inside that we have wrote some payload of reflected accesses. Okay, we are not performing that reflected accesses directly, but indirectly with smuggled request. So we wrote this comment, and with some the next request is append to comment is if reflected unsafely its header. Okay, whatever the theory. So reflected accesses payload you will put inside comment the way you do in accesses. Okay, and when you will process this request, by default reflected accesses or this comment, that comment will get stored to backend server. And whenever anyone user will load that page where the comments are visible, then that reflected accesses will be seen. So basically, why we are saying zero click accesses? User or client has nothing to do with it. Simply we are submitting the request, they are not interacting with it. Whenever they are opening the web page, by default this thing will happen. That's why we are saying zero click accesses. How we did? Using HTTP request smuggling only. Okay, and this is how only we can add some requests which can take cookie session of other user, or can perform IDOR, or maybe you are not having access to delete some data from the, you are not having authority, like you're not having access to delete data, but by smuggling request you can confuse server, backend server. Then cache poisoning and cache deception. What is cache poisoning? Anyone? Okay.
And suppose there is a GANT endpoint
Hmm.
which shows chaos script,
Hmm.
and there is one another direct endpoint which shows the user data. Then we can confuse the, we can pin some endpoints in chaos part to get the user data.
Yeah. So cache poisoning. First of all, let's understand cache. So basically, whatever the data is used frequently, that will be stored in key value pair, and we will be retrieving it from the cache only. Okay. So cache poisoning means you are trying to confuse the value part. The key part is there, and you are storing some other value for that key only. And this is so. For example, there are 10 keys, okay, K1 to K10, and for that respected we have 10 values, V1 to V10. But we are training our browser in a way so that some value, for example, K3 values will get changed to V12, let's say. Okay, so the other time the other users will try to fetch data of K3, then they are not going to get V3, because that is already poisoned, and there what value we have there? V12. Okay, so this is how you train data, or you try to confuse server, like K2's answer is K3's answer is V12, not V2. If you'll do multiple time, like uh, if I'm looking for K2 and the response is coming, somehow you're obfuscating, you are doing some attack, and K2's response is V12. So cache will understand, okay, K2's data is V12, it will update the cache, and this is how you can affect other users, because when they will browse for K3, they will get V12 instead of V3. Okay, cache poisoning. Now, how it will like take place here? So in this, we are smuggling request, clear? So this is request A. This is the one request only. But if you see in a part, the first part is request A, the second part is request B for backend server, not for front-end server. For front-end server, this is the one request only. For backend server, the above part is request A, the second part is request B. So it is going to generate two different responses for both, right? So for request A, the response should be response A. For request B, the response should be response B. But due to smuggling, what is going to happen? We are sending this request. Basically user is not aware of this, right? So this request ka response is response B, the end response, because we are sending single request, but backend is taking it as a request A, request B, response A, response B. But front end is waiting for the response for request A, and the end result is response B. Once again, see, front-end server is having single request. Front-end server is considering like this is the request A. This is the one request only. But the back-end server is taking it as a request A plus request B. So it is going to generate two responses, response A and response B. But for user, it will be like, I have sent only one request, request A. And the response is response B. But actual response is what? Response A, the first part ka response, right? Got it? Okay. So this is how we are poisoning the cache. Because for, see again, request A, request B, the answer will be response A for the first part and response B for the second part. But to the user, to us, it will be like I have sent only one request, smuggled one we don't know, right? So we have sent one request and the final outcome will be response B. Right? Final outcome will be response of this part, not this part. Because first response is that, second response is that. But final outcome is response of the second part. So this is how we are confusing the server. We are updating the cache. So any other user is requesting for this. Now they have not smuggled the request. They are just purely sending this request. But in cache, what we are having? Response B. Right? But the answer should be what? Response A. Right? Clear? So this is how cache poisoning and cache deception via HTTP request smuggling. Okay? Recently, we have seen front-end bypass and then zero-click accesses. This is cache poisoning and cache deception. Then turbo intruder verification method. What is this? So, if you can send this request one time, you can send multiple times by using intruder, right? Multiple requests at a time. That settings we have in Bob or in any interceptor. So, example, we are attaching, there is a request of getting cashback on particular coupon, okay? We have smuggled one more request and we are sending the same request multiple times. And if there is some problem with backend, then the like all of the, for example, we have sent this request 3 times. So 3 times cashback you will get because at the time you have fired the same request, right? So this is how you can, even this can comes to the business logic, right? So we are using server only. We are, with the help of request smuggling, we are taking advantage of reflected accesses and then this business impact you can say, because you are getting cashback for, you have only one coupon and you are getting cashback for multiple or 3 you can say in the our scenario. And in poisoning, you are confusing server and like you are misleading the data, right? You are misleading the users and you can take more advantage of it. Okay. So till here it is clear. Can we go with labs? We are looking at CL.TE vulnerability. Okay. So for, okay, first of all, let's see this. Okay.
Ma'am, can you show me where is we can see CL? Ha-
You can see, and that's what we are seeing. All right. So /r/n antaryami /r/n. Okay. So just by clicking over this, you can see the escape sequences or CLF. Okay. Carriage return line field. Carriage return means start of the line or sorry, next line. Carriage return means next line, as you see in your coding languages also. So next line, and in next line start of the to start from the cursor, like to point the cursor to the start of the next line. So for that we have /r and /m. Okay, so now you can see content length as a 6. Okay, how we count? See, 1 after header ends, transfer encoding chunk header ends. So 1, this whole Rn will be considered as a 1. Then 2, the second, okay, this after chunk, the first Rn is 1, second line Rn is 2, then 0 is 3, Rn is 4, and next Rn is 5, and G is 6. Okay. At the end of the body, the Rn we have, we don't count that in case of content length. Okay. At the end of the body, the Rn will be excluded in counting. Okay. So for this, we are checking CL.TE vulnerability. So my content length is good to go. Front end is okay. Front end said yes, you can go ahead. But in case of backend, let's see. Okay, all set. See, method is post. The HTTP method is 1.1 because in 2 it will not work. Let's send this. So we got 200 okay. Okay. See, transfer encoding is just checking data till 0 because, sorry, backend is taking data till 0 because it is using transfer encoding. So the rest of the part G will be considered as another request. But where it is? This is the simple response, the positive response. But if you will send it for the second time, what is happening? Is there any it? The another time it should come G post or something. Okay, this is set. Are we missing on anything?
HTTP 2.
Oh. Okay. Okay. Second time it is showing 403 because unrecognized method G post. This is just example. So we are taking G just single later. Otherwise you can add some request and try to get some data, some cookie. Okay. So is that clear? Let me run it again. For the very first time, it is giving you 200 because we are just considering a genuine request ending with 0. But for other part, we are just having G and G get combined with the post, the headers and all. So it is showing like unrecognized method G post. Instead of that, you have to write some correct payload or crafted request. So this was CL.TE. Now let's look at TE.CL. So anyone of you can explain TE.CL?
Content using transfer encoding and
Someone else.
oh.
Thank you. Anyone else? TE.CL. What is TE.CL till the time I open the lab?
Front end uses transfer encoding and backend as content length.
And what does it mean?
So front end will read data till 0 and backend will check the content gap.
Okay. We are going to do 3 labs. So meanwhile, anyone can explain CL0? What was CL0? Anyone from this side? Arey, what is CL0? What front end is using? Content length. And the back end is using? What 0? Transfer encoding 0 or? No.
Content length.
Content length itself only. Both servers are using content length, but front end is considering the actual value of content length. Backend is considering CL as 0. Like, okay. Okay, so this is the server ID of next. TE.CL vulnerability. So what are the things we have to consider? Okay, TE.CL means backend is going to use CL, content length. So we have to keep it in mind. See, whenever you change, right now content length is there. Content length header is there in this. Okay, let me show you. So let me remove this connection, keep alive, we can keep, otherwise also it is by default keep alive. And we have to add content length, transfer encoding. To save our time, we will take it from here. Okay, let's try to grab the request. So in case of TE, the front end is using TE. So the request, the body part should end with 0, chunked, right? And we have to confuse CL. Like if it is ending with 0 and the total data is 20 liters. So we have to write content length with 10 or something. So rest of the 10 liters will be considered as another request. Clear? Okay. This TECL. So let's take this example. Okay. So content length is 4. What I said? Whatever the request part is, we'll consider content length lesser than that. Okay. T is good. Like front end will be good all the time. So it is ending with 0, chunk, done. But for the backend, content length should be lesser than the actual body. Why? Because we want to smuggle a request. So we'll give the length till the part we want it go as a first request. So let me on this. So you will start counting from where? Chunked. After chunked. So one. So in this content length is below, right? Okay, okay. There is some. I have pasted it 2 times or what? That's good. It's good. Correct. So you will consider after first transfer encoding chunked. Okay. Line number 6. So RN1, next RN2, 5, 3, C, 4. And done. Because content length is 4. What we are saying this for backend server. Because backend server is using content length. For front end, the request is still 0. Okay? What I'm saying? Till 0, front end request is till 0, the whole request. But for the backend, content length is 4. So it will take it as a till 5C only. After that, it will consider as another request. Clear? Okay. Let's try to do something. So observe, content length is 4 right now. But if you observe now, the content length is getting updated, correct? But this is how we cannot perform attack. This is how we cannot perform attack, right? Because content length should go 4 only, not more than that, not the actual length. So in bufs or in interceptor, you have to do some settings so that content length should not get updated. Clear? So what we are going to do, we'll make it again 4. Yeah, we'll do everything. So, but first of all, right now what we were observing, content length get updated, whatever data we are providing, okay? So we have to stop that first. HTTP2, definitely we have to change that too. And the request method should be post, not get. Let's do one by one. First, we'll change the method. Sorry, change the method. Then HTTP 1.1, done. Then we have to stop repeater by updating length automatically. So that's done. Oh, okay. All set? इसने डेटा भी उड़ा दिया. 1 second. There is some time delay. क्या request था? 1 moment. Let's take it again because okay. Change request method. Okay, this is set already. नहीं लोग ये Okay, first time the response is 200, request is good to go, but the rest of the part, the G post part is not covered by backend. because till 4 only it is taking. The second time, what response we are getting? Okay, unrecognized method gpost, the rest of the bar. Instead of that, you can craft whatever you want, the request, the cookie, whatever you want. Okay, so this was TECL, TECL. Hope it is clear. One more time, or it is clear? Clear? Okay, can you please explain TECL as per the example? Try. Yes. So what front end will consider till which line?
Yeah.
0 till the end, and back end will consider till the 5C, right? 1, 2, 3, 4. So till 5C as a first request, the rest of the part as a second request. Simple. So we got two responses. You can see it again. First request was genuine, proper. So we got 200, and the rest, a second part of the request, we got some different response. Okay, and this is how we were saying a cache poisoning. So in cache poisoning, this is what happening. See, this is the single request for front-end server for user, right? But at first instant, we are getting this response and this as a second response. So for us, the final response is this, which will be reflected to the user, to client. Okay, and this is how we are confusing the cache, because for this request, the output is this. But in reality, the output is the previous one. We have smuggled the request, that's why we are getting the another response. Okay, this is how cache poisoning and things are working. Okay, this was TECL. Now the turn for TET. In TET, what we were doing? Obfuscation. Means there were two transfer encoding. One's value was proper chunked, and the another transfer encoding was having some random value, which was confusing backend server. So what backend server decided? Let's forget this. Let's take content length only. Let's keep about the content. We are not getting right value for the transfer encoding. Let's override with content length, and that is how it was happening. So it's time for the third lab. Meanwhile, what you can explain? Delay. CL.TE time delay, if anyone can explain. From backside? Yes. CL.TE delay. Yes, you. आपके पीछे. Oh, yeah, I was explaining. I felt you were discussing something advanced than that. Okay, no problem. You can explain CL.TE time delay, or any one of you is fine. You can discuss and explain. That is also fine. Okay, CL.TE time delay probing I'm talking about. This was simply CL.TE confusion, okay? I'm talking about time delay. We are confusing server, we are delaying the server, we are delaying the response. That is how we can create impact, right? Something like this DOS and all, right? We are delaying the response. So yes, anyone थोड़ा थोड़ा mix करके भी बोल सकते हो, that's fine. CL.TE time delay probing.
Not giving complete body.
Not giving complete body in CL.TE time delay? In CL.TE, how we can create delay? So the delay is created by backend. So focus on that and just try to correct. Because CL.TE delay. So backend ko confuse karna hai. So we are not giving 0 and backend is looking for the 0 and it is not getting and delay is getting created. Okay, the next TE.CL delay. Going good. You guys are getting clear. Like what is TE.CL delay? So backend is looking at CL and there a delay will be created. So what will be the concept? Increasing the okay. So backend server will look for more content and it is not getting, that's why there will be a delay in that. Okay, great. Okay. So almost request is ready. Then we'll talk about defense, then we'll sum up. Okay. Have you read any bug bounty case study for the HTTP request smuggling? Any one of you? Okay. You can, let's do this first. At home, you can try to obfuscate this data, like add some more data instead of only G post. You can add your data. You can try with some bug bounty cases.
Yeah.
I'll send some links of bug bounty cases in group so you can study that. You'll
Nothing I do.
okay. Where is the get request? Do anyone know HTTP 3? HTTP 3 is there in market or yet to come? Hmm? Oh, okay. Hmm? HTTP 3 there is in market or it's yet to come? And what is the difference between that? Okay, cool. Oh, this. So this time it is TE.TE. First of all, change request method and HTTP 1.1 is only there. Let's remove this. What we are supposed to insert? 2 transfer encoding and 1 content length. Okay. Let's save our time. First transfer encoding will have something like some chunked and the another one will be random data and content length as we want backend to take. Okay. Okay, so content length something 4, transfer encoding chunked, transfer encoding second time it's cow. You can change it with anything, any random value happy. Okay. So if we switch it on, you can see after happy, you can see 1 RN, 2 RN, 5 3 C4. So we want backend to treat this request till 5C only. Clear? Okay. So let's send this. First time we got 200 okay because front end, backend. For first time it is taking transfer encoding as a chunk. All good till 0 and request is fine. But for the second time, again, HTTP 2. In HTTP 2 there is no problem. So yeah. Okay. Unrecognized method gpost. But every time we are getting the same kind of responses only. But the method, the terminology or the concept is different for all the time. Okay. At the end, we are going to smuggle one request, one additional request. That is only we are doing. So response will look same for all the labs, but the method we are using is different. But why to try for this? Because every time the server will be using different technology. So it is not necessary if on one system, if it is working CL.TE, so for another one, it will be, might be TET. It depends on what mechanism they are using at front end and back end in that particular system, right? Okay, that's it for the lab. Let's go for the defense. Before telling the defense, you guys only tell me. You would ask something?
Question that if we are smuggling from front end as a one request early, and why do we have to click 2 times slightly in the box suit? Like it is going as
Be-
one request early, right?
because in Absurd, it will go step by step. You have to take the step, like see, whatever you are doing, whatever task you are doing, you're loading a page or something, there are many things like loading data, some comment part, and so many. So if you load one page, there are so many requests when go in backend. But in interceptor, we do step by step. That's why we have to click 2 times. Otherwise, it will be one time only. Okay, because for example, if you are loading a page, for example, if you on the intercept and you are loading a page, you have to click next, so still it loads fully, right? So that is why in interceptor it looks like that. Okay. Ha. So instead of explaining, can you try with what defense mechanism we can use in HTTP request smuggling? How we can stop backend server doing this, like entertaining smuggled request? We want to stop that. So what we should do? You said like this all problem is because of both server are using different mechanism, right? So how you can stop? If standardize, if both servers use same, then we can stop. Okay, so first of all, we can try front end server and back end server should use the same method, either CL.CL or TE.TE or TE.TE or CL.CL, right? Okay, this was for HTTP 1.1. Okay, so detect suspicious framing, the one someone was saying about firewall, right? Definitely, in defense system, what you have to do, first of all, request smuggling firewall. First of all, you have to filter request at the very first end only, when it is going from front end. Okay, so it should be identify conflicting HTTP framing, and then block ambiguous request if there is something smuggled, additional header, copied header. Okay, that you can check for. Then validate headers, like what is the value of header content length, is there like two headers for transfer and coding, do we have CL and TE both, because it only one is required, either CL or TE. So we will validate that at the front end server only. Now at the socket layer, standardized socket handling, like it should be like one request, uh, additional request should not go along with that. Then control connections. Control connection means, again same, for one request there should be only one response. Additional request should not be allowed even though it is 1.1. So we have to take care of that at this end. Reduce parser difference means we are getting, for cache poisoning example, like for same request we are getting different response because we have smuggled one request. So that parser difference should not be there for same request. Then additional defenses you can see, prefer HTTP 2, very simple. Don't use HTTP 1.1, right? So prefer HTTP 2 and HTTP 3, which is not possible because there are so many servers still have not adopted HTTP 2 or 3. That's why that we cannot avoid, but we can prefer. If we have option, then we can prefer. Then normalize headers, handle host, authority consistency, secure downgrades. See, what we said, okay, HTTP 1 point, HTTP 2 or 3 is not there for that server, then what we can do? Okay, you can at least secure the downgrade. For example, if front end is using 2 and backend is using CL, so it should not obfuscate some data, it should be verified. The way we are verifying it in first case, the way we are verifying it on front end server plus backend server. But in this case, secure downgrade, just you have to take care of the backend server because backend server is using HTTP 1.1. Downgrade is required, understood, but that should be secured one. The another one is strict cache control. So to avoid cache poisoning and cache deception, then monitor anomalies, detect unusual HTTP framing means additional headers. We are using transfer encoding above, then below also. In same request, we are using it 2 times. We are writing method 2 times above delete or get, and below also we are writing one more request G post and something. So monitor anomalies and continuous testing, because even though HTTP 2 is there, we cannot relax because might be backend server is using 1.1. So we have to keep monitoring, we have to keep checking logs. There are so many cases recorded, but we'll talk about 2 right now. Case study, Zomato via Akamai. So in this, the attacker have attached get request along with the delete request. Basic CL.TE vulnerability, and account takeover was token theft. Sorry, this was token theft. And the next one, Slack mass account takeover. In this, in one get request, it has crafted. You can go with this link. I'll share this PPT or might be at least case study link. So there you can see the whole case study of it. In one get request, one more get request was crafted, and simply like IDOR, he was able to take session of other user, PII data of other users basically. So this is what bug bounty, and you can see the bounty, $7,500, and for Slack mass account takeover, it was $12,500. Yeah, 12. Zomato one, $12,000, 12,000. And there are so many. I have listed 4, but time is up. Okay, I'll send the link of this bug bounty reports. You just go through it because you are clear with the concepts. It will be very easy to understand bug bounty reports. Okay, that's it from my side.